So as I click on this challenge, which is what we had decided, and what I like about this is sort of like this easy ways of working together. And I'm just using this to refresh our memories on this. And you can see that if I go here, I can go to my work, and you can see that I had a notebook. And I say that you have to come up with a way to list something that you can get easily started with. So you can see that, yeah, I won't have to rerun it, but so Kaggle allows me to integrate, and it's actually pretty easy. I think this was a good thing, because you can like add data, you can add your own data, you can load your data, and this always launches with their code. So if you see that here I'm just importing, this, I think Elmira explained this the best, which was just sort of like you're just opening a book and deciding what chapters you'll be reading. I like that analogy. And I'm just importing more things, and it's just telling me, you can see already here that we don't have to split. In this case, you didn't have to use the test splitting, which we spent quite some time on last time to figure that out. And then this is for plotting, so you can come here and you can see that mine is pretty, the short version, not like the long import read CSV. I'm not saying that mine is correct. Really, you should do the better things. You can see here I'm using the head function to just show me that, okay, it's imported, okay. I see what the data is here that I do not know. And then you can see that I use the info info command, which is what we learned last time. And I said I really like this because I've never used it before, where I know that I should have 1460 entries. And if I look here, I can start to see the early only has 91 entries, so then I start to see fireplace, there are only 770 entries, and something like pool only has 7 entries. So some of these things, just by looking here, I know that I will either have to drop them or really investigate them. The other thing that we learned about last time was sort of looking at these data types, right? When you see an object, then it's maybe like a categorical variable. So you should explore to figure out what's there. When it's an integer, it's going to be just a number, which can also be a decimal. So, so you can see that, remember, we use describe to see any, sorry guys, I have a dog, Simba, Acha. And so you can see that here I'm using the describe function, and really what it does here, it's just going through the numeric values and showing me what the 25, 50, 75, and maximum minimum values are. So this is a good way to understand the data. So for example, the years of remodeling are between 1950 and 2010. So if someone told me predict, and this was what we learned last time, predict a house or that was remodeled in 2015, then really your data doesn't represent that. So you should be cautious about it. Then you can see I just really literally copied what is an object because I wanted to understand the data better. And all this exercise really I was just trying out to maybe, so you can see the zoning, these are the different types of zones, and there's obviously descriptions for this. I think this is pavement versus gravel. So I know that most of the data in this data set is actually paved, and gravel is not. And because this is a task on feature engineering, and you can see what the alley looks, the lot shape, and literally I'm just copying these things and changing the name of the column here to see the functions that are there. And then the other thing that we really liked last time was this figure drawing, and all I did really was copy the same code. And if you see here, what I'm doing here is saying, generate. So I imported my data frame as data. In the other place, we import it as housing. And you can see here, I come in and say, draw this figure. And this was good because I can actually come here and, see the images just because of the way the project is set up, and I can see, okay, there's an attribute histogram plot. And at this point, I can even download it, okay? And you can see that, because we know that this data set has quite a bit of fields, but you can see the same histogram that we were seeing in the other places. I just downloaded mine. Obviously, ID is probably just the house ID. You can see sort of like the distribution. Last time we were seeing more of this left-sided and then with a long tail. But here you can see, oh, okay, this is the ERA model, what looks like classes, what doesn't look like continuous numbers. You know, then when I'm seeing this, I'm thinking to myself, maybe I should try and bin these categories so that, you know, they make sense and can fit into my model. And then as we'll go through the rest of the chapter, you'll see that some of these categorical variables, you should just use the one-hot encoding to represent them in the machine learning. And so this is what I was able to do. And then I'm like, okay, what I wanted to know is how do, you know, maybe let's say like the lot front edge, which is this one, which I know is like just several numbers. So I go in and zoom in onto this specific plot. And here I was thinking, okay, I'm seeing that most of my numbers are here. And I think there was a question here where Elmira last time asked, why are we discarding some numbers? And that's just really to prevent the overfitting. And I can describe here, I was trying to look at, I'm not saying this is the correct thing, I'm just showing you what Judy did. You know, you can see sort of what's the minimum and the maximum, and you know, and then come back and decide to bin these values. And so guys, did we get to I think this was where we ended, right? Figuring out the Pearson's curve, correct? Is that where we've gone? I'm back to our notes. Am I just talking to myself?
Yeah, we ended there.
Hey, okay. So anyone else who attempted that task or had different thoughts? I've not completed it clearly, as you can see. I was just going through what we discussed last time. Just to recap and just show you. Really, you guys, you're not saying anything?
So I didn't do anything on the Kaggle.
Okay.
But just now that you have Kaggle up, so the Kaggle kernel, like compared to Colab that we were using, we introduced in last session. So we need to like I am like getting more familiar with like how the data and like the file system is organized there. So for example, on a Kaggle node like kernel, you're not able. So the input is coming from whatever challenge you're being involved at, and then yeah, so there. So and then the output is what you actually can manipulate. So the fact that Judy was able to like present all of these data was that in that when we defined path we basically brought the input to the output working area. So you can yeah, that one, and also so those are like the input, but then when you defined path for like images and stuff, so that was where you copy the stuff to the output on your working directory. Otherwise you won't be able to like manipulate those or like save or anything.
Yes. So this the reason, by the way, I didn't even write this code. Remember we went through this last time where we're saying the OS path and project root. If you use relative things and you set them up this way in your Kaggle, your whatever notebook you're using, it's always going to be easy to, it doesn't matter whether I'm running Colab or somewhere else, right? Because it's relative, it just goes back to where it's supposed to be, okay? So that's the joy of spending the time setting up your base thing, your base code, so that when Judy gives you a new project, you'll just go and be like, okay, I'm just going to use this. You know, you just load your data and you start running everything together. And so that's sort of like the advantage and sort of something that you have to think about. And especially for for the non-full-time technical people, this is how you're going to always remember, right? Because you'll take you a while, then you'll be going back and be like, oh my God, what was this again? And it's just gonna use a lot of time, okay? Abby, were you able to run the rest of the code, or you still kept getting errors? You got
Yeah, I was so happy. I was like, yay, finally.
Okay, awesome.
It worked.
Awesome. Okay, guys, you ready to move on to the book thingy? Are you still, I mean, I like reading this book. I would still read it alone, but I think it's nice to try and please feel free to jump in. And Pri, do you have something to say? There's a lot of echo in your background. And I think we have someone new we haven't had before, Nazanin. Do you want to introduce yourself?
There is fan noise on my end.
Sorry, what?
The fan is revolving at high speed, so that's the background noise.
Oh, wow.
In India, it's a bit hot.
Okay. Okay.
Well, I wanted to point out one thing. Actually, they have provided their own Docker. So if anyone wants to set up it on their system, they only need to build the Docker, and everything, every dependency, you will get what you need. Like last time, I remember you showed that URL lib was not working, so you imported different way. But if you are using their Docker, the code will run exactly the same way they have provided in their notebook. So if anyone wants to try it, they can build their Docker.
Okay.
What was it again?
Could you explain what Docker is, and could you put those instructions on the channel? And if you're not on this channel, please let me know, and then I'll add you.
Yeah, I'm on this channel.
Yeah, please.
Well,
could you
if you
explain what
consider,
Docker is?
Yeah, I'll try. If you say Docker, it's the minimalistic operating system you have running on one top of your OS. Like if you're running Mac or Ubuntu and you want a Linux or a Windows Docker, you can easily run it on your system. It's different from virtual machine because it's not creating any type of separate system for you, but it's just providing an abstraction layer in a separate container. So you can think of it as a virtual machine, but in practical, it's not a virtual machine. It's just a minimalistic OS running in a container, and you can install your dependencies on that, make it in a Docker file, and distribute it. Can I share my screen? Hello.
Yes.
And it's just very similar to what, if I wanted to explain virtual machine, I would have used the same descriptions that you said.
Yeah, so it's a platform for running virtual machines, but it's just like it's the most common thing. So Docker, when people say Docker, it's almost synonymous, but Docker is a product,
well,
you know?
Yeah.
Docker, like, I'll check the slide to see how it's right. So I can like.
You're a little distant, but what Docker does is that if you have to run many things at the time, right? You don't want to keep reformatting your machine. You want to start with an instance that you're not installing anything, and you run it, and then you end, and then you move on, and you can. So it's a very modern way of distributing code. So if I say, Abby, here is this Docker, all Abby needs to do is just put 2 commands, and the system is up, you know, and yeah. So that's why. Okay.
Yeah.
So
that's what it,
yeah. So I'm just going to quickly run through this. Nazanin, please feel free to introduce yourself when you have a chance. Welcome. So we loaded the data, right? You saw that my data was loaded very differently. We saw the information. We did the value counts for categorical variables, which are object type. We used describe to see the integer values, and we set up our plotting because matplotlib requires for us to load the plots when you're in here, and then we start to see the plots, right? I mean, I just replicated this code and you can see on a new data set, right? And then what I wanted to say was sort of like these histograms, right? You could start to see that even here, I'm like, okay, that maybe the maximum refurbished area, or when the garage was built. So you can start to figure out some of those trends about your data, because you're assuming you know nothing about this data, and you have to get familiar with it if you're going to pick up what features are going to be the best, right? And so like for this one, it said like it's very unusual to expect that numbers are 1, 2, 3 in terms of medium income, right? It will be unusual to have $3. So you can start to see, if I look at this example too, that there's some numbers which are different, and that's important for machine learning because you kind of have to normalize all the numbers in the same place. And so so you look at this chart, you figure out some of the things that you're starting to see, and you can either decide to go get more data or talk to someone who's an expert in the field that you're doing. Now, my example didn't require test set because that's already split for you, but this is going to be something that you do. Do not look at the data because your eye apparently can figure out the trends and you can bias yourself. And so, this is called data snooping bias. Here we go through many, many versions of the test set. What we said is that the moral of this story is that you want a test set that persists, right? Because if you restart the code, and you will have to do this unless you're like super, programmer, you want to have the same test set on all subsequent things. And so what was interesting here is that we use this sci-kit learn program function and method, which is a stratified shuffle split, and it's splitting housing, and it's also using housing income categories. And the reasoning for this is that if you use this stratified, you'll see that if you compare the overall ratios and the stratified, you see that they're pretty well matched, because you don't want to have like your sample size. So remember, like I had started to draw categories of some of my variables here. If you start to look at these figures, you want your biggest test set to represent the same distribution, okay? And so if you don't want like to have 500 of this sample and 200 of this sample, because then your model is not going to work well. So this was sort of all those other things were to bring us to this. And then here they just remove the income data categorical attribute just to make sure that you're not because you were just using this for the test set generation. So then we went here to the gain insights. I thought this was a great view. Remember, we saw this, but it's not very noisy till we use this alpha function that allows us to almost weight and see where some of the trends we see. Then we load some colors using this CMAP. These are just functions, you can just copy them. And then the next thing which I thought was interesting was how they went on, and I know we don't see it in the book, but they went on and put on the map, right, of California. So then now we can see, if you're watching the code, you can see that you see the map of California. Now, I do need to start my thing. But so then we went to correlation efficient, which I thought was probably one of the biggest takeaway for me for this chapter, right? Because it's how you discover the data. If you don't know the data, you create a matrix using your data, using this function, and all of a sudden you sort your values. And you can see that I actually ended up doing the same for my code on. I'm not trying to confuse you guys. I'm just trying to show you that I just use the same methods for something similar because we have to experiment and experiment. So you can see that here I'm making my correlation matrix. And because the task here is to predict the sale price, then what you bring back here is, show a correlation matrix of the sale price and sort your values. So now I can see that the overall quality of the house, living area, garage, those are the top, the top correlated values. And that means the more the overall quality, the higher the sale price. And the things that are negatively correlated are here. And you want to avoid the zero things. And so that's exactly what they did here. They move on to the median house value. You can see that the median income and the total number of rooms are very highly correlated. And so this is this. And you can see, this is just sort of explaining some of the like, this is zero correlation, this is in the negative, and this is in the positive. And so what they went on is to use this function, this method for scatter matrix, which is from pandas. And these attributes that they're getting are based on what they think are the top performing areas. So median income, total rooms, housing median age. You can see median house value, median income, total rooms, housing median age is, so these things is what they want to draw a plot of. And then to start to see, are there any trends if you start to think about the lines, you know, and fitting. And, you know, here what they notice is two things, right? And I know I'm just recapping from last time because I remember going through this, that the median house value here of 500,000, this is the maximum that you can get from your data set. And then you can see an overall spread, you know, going up that way, right? With a positive correlation. Guys, are we together, or I'm just talking to myself?
No, we're together.
Okay. Someone should be saying yes, Julie. But anyway, next time one of you is gonna do this. So I'm not doing it next time for sure. And we're gonna agree on who's going to do chapter 3 next time. Please feel free to interject with any questions. So here you see the correlation is strong. You can see the upward trend and the points are not too dispersed, you know? And so then you start to again come back to the things that tell you that this is 500. So here I think Toby had a question here last time, what was happening? And here is to start to say, could you look at some of these values and start to generate more derived values, right? This is going to be super important for this task, right? Because could you say that maybe it doesn't matter whether it's a half and total and full bath, maybe you could come up with total bathrooms, you know, 1.5, maybe that's what matters most, but we won't know those things. You have to derive those features and those variables. So for example, here in our data, we had total rooms, but we also have the household. So maybe it's rooms per household that matters, or total bedrooms over total rooms, so bedrooms per room or population per household. And all this is just a simple division to get new variables, okay? And if you do this again, because you don't know if they're important, you go back and do your correlation again, and you start to see what are the trends you see. So you repeat the same thing again. And this, I really do believe we'll have to keep doing it a lot. So you remember in our data, we only had total rooms, but now when we make rooms per household, we find that it has a higher positive correlation, right? So that means you could get rid of the total rooms and use rooms per household. If you look at total bedrooms and bedrooms per room, in fact, now you see this one is close to 0, so not much of a difference, but now this becomes a negatively correlated function. But that's how you're learning with your data. And so, you know, so we were starting here where we're going to preparing your data for machine learning. And here you always better to work with a copy of your machine, your data set, because if you've worked all this, you know, cleaning, and that's, I mean, you don't want to mess things up at that point, okay? And so the first thing is how to drop your data. Let me just pull up my notebook. Guys, give me 1 second. But the first thing here is how to drop null values, right? And if you remember the info command we went through, we saw that. One second.
I can add something here while you're looking at your notebook. So
yes,
the code that is high up there, like housing and like housing labels. So we are basically, so we're trying to split the whole data columns with the column that is our output, our prediction, separate from all the features that we want to predict that column. So the housing label is the median house value. That's what we are trying to like get at. So we're creating a different data set only containing that column. And the rest of the house is everything else except for that column.
Yeah. So, yes, that's okay. So this this area here was all about dealing with negatives, okay? And if you look at so this area of dealing with negatives, okay? And I'll come back to the code here. But so you can use drop, NA, drop, and fill NA methods, okay? Those are the three things you can use. And you can see all what they do. And in the code, you'll see what happens. So for example, here, it's just saying, you know, so drop labels for the training set, you know, so we're dropping the median house value because you, and then you're copying the housing labels here. And so the sample, let's say, this is just to create a sample of incomplete rows where you're just picking out your data and say, show me anything that is now. And if you look here, total bedrooms were NAN, okay, NAN. And so if you say option 1, which is drop NA of the total bedrooms, you see that if you look at the method, the data frame at that point, it drops everything, okay? So drop NA, okay, so drop NA gets rid of the everything corresponding districts, and then drop gets rid of the attribute, and then fill NA can fill, set the values to some value. So if you look at option 2, which is drop, if you look here, total bedrooms, right? So we just drop this column of total bedrooms, but now we still have all the other data. Am I confusing people right now?
Yeah. So my question, my question was more about, NA means not a number, correct? Or is null, it's empty or missing, right?
I think missing.
Okay.
Now.
And then I think I have like a semi answer to your questions, that I think this is the data that's defining what is defined as missing. So we can see that this is NaN is something that is in our data, and the NA, which is one of the data frames functionality is pandas. So this is how we define what is missing data based on our data.
Yeah, so these values were missing, and the only way we know that these values were missing is that if you remember when we went through our info here, right? Housing info, we knew that we have 2640. So the only thing without 2640 is the total bedrooms, right? So it's missing some values here. And so we just created a data frame that says, you know, show me the values that are missing. Just create for me that subset. And it's just to explain these three so that you know what to do, right? And so option 1, if you say drop NA, it drops everything and the corresponding rows, right? 46, all these 5 rows will be dropped, right? But if you say drop, it's just going to drop the row, the column for total bedrooms, but it will leave all the other data intact. But what you want to do is, so you can also just fill the value with something else. So for example, here, what it did was say housing, total bedrooms, give me the median number of the values. And then now instead fill NA, which is just use this median value and do it in place, right? So now you can see that in this case, if you compare the 3, this one was now, when you use drop NA, it dropped everything. Then when you just use drop, it dropped the column. And in this case, when you're filling, it just uses the total bedroom, okay? And so what they go and say is that you don't need to do this, right? And that's why, like, your final code, your final notebook should really just have very few codes, right? Because you could say, I don't need to do that, or I may remember that I can use, you know, either I can either get rid of the corresponding districts, get rid of the whole attribute, or set the values to some value, 0, median, or mean. And or I can just use the scikit-learn method, which is simple imputer. And here they're just saying that you can use simple imputer, fill, housing fit. So housing, this variable is just housing drop ocean proximity axis 1. Wait, why did they do that? It's been a while. Okay, since the median can only be computed on numerical values, you need to create a copy of the data without the the text attribute, ocean proximity. So if you go back here and look at the info, right? This you always have to keep like going back, and you don't need to do that because you could even just say housing.info and it's going to come back again. But if you look here, if you look at the data types, right here, we're looking at the number of columns, what's null, and what's the data type. And if you see, this is the object, which is why we ended up looking at the value counts that we saw. One is ocean, inland, near ocean, near bay, or island. And we look at, so if you want to calculate a median, you have to drop those values that are objects, they're not floating. So if I was going to look at my example that I was doing on the Kaggle, I would say drop all values that are not object, and it would be more than one row. And then now in that way, I can calculate the median value using this sci-kit toolkit. And if I do that, using this simple imputer strategy median, so this is what they're just dropping the value that is there, then you know, fitting this, and it's going to show you what the imputer statistics are and the housing median values, and you can just x is equals imputer transform housing number, and now all of a sudden you fill your data frame that's going to fit with median values wherever is now. That's what they're trying to do with this code here. Okay, so now you can see that when we calculated our own median for the total bedrooms, it was around 433, and in this case, using the sci-kit plan, it still comes to around 433 in terms of strategy.
I have to some.
No, it's actually, it comes to this, not 433. So this was just the 433, but this is what it comes to. So it starts to get different because it's averaging the median values across the whole row. So big thing here is dealing with incomplete data. You have to come up with a strategy, and I'm pretty sure don't get bogged down. I think the learning point here is just to say these are strategies or you can use. You can either drop the attribute. So for example, if you only have one value in the whole data set, there's no reason for you to you know, use that one value. You'd rather just drop all of them. I see lots of, from Toby, there's lots of scratching. Am I confusing people? Someone? Huh?
I have something to add here.
Yes.
So I think like, so either we can manually, as you said, we can manually fill those missing data, either to like completely discard them as column or row, or we can replace them with whatever value we want, mean, median, whatever we decide. Or we can use one of the sci-kit's learn tools, which is this, whatever it was, imputer. So this imputer will is basically something. It is going to predict a median, because we defined our strategy as to be median. We could have used a different thing, and then it will be first. We can either fit that median into our calculate. By fitting, we mean that calculate the median for our data. And then when we feed our data to this imputer, it will calculate the median for that using fit method. And then if we use the transfer method, now it will put whatever those median data into our missing areas. And then the other thing which I found is very important is that the output of this transformer is a NumPy array. It's not the same data frame that we were using with
Pandas.
Yeah.
This is and we have to be cognizant of that, and we have to make sure that we change it, the NumPy array, using that housing underscore tr. So that is how we change that output back into Pandas data frame. Otherwise, we wouldn't be able to use the columns and the indexes as we were able to use before.
Okay, absolutely. So this was important here, this sci-kit plan, and because it just really talked about what you can do. And I do think you have to spend some time looking through this, because I think once you go through everything to the end, then you can understand sort of how to impute some of the things, right? So the estimators, and this is an object that can estimate some parameters based on a data set. So and you use this by calling the fit method, like the simple imputer, right? You know, and like the imputer strategy. Then there's a transformer, which can transform the data set, right? And so at that point you use transform. So we've said, if you look here, we said fit, and then we transformed the data set, right? And then there are predictors. And so these are like the linear regression. And so they just say that sci-kit is very, very mature about the design principles, and this is super important. And I think it comes home, it comes to wrap around pretty well. Now, if you look at inspection, if you're just looking at the imputers, if you just put the underscore under the thing like imputer statistics, then you can see the variables. So for example, here, if you just say imputer statistics, you can see what the array was. You know, that's how you just see the values here. And you can see housing, NAM, median values, they're the same. But just because of, just when you fit this data, if you want to see like some of the statistics, you just need to put an underscore. And then, and then there's this idea of creating a pipeline. This was the other thing that I really liked about here. Guys, don't get so bogged down with the details. I just want to make it easy to understand the text. But let's, you know, like I said, I just don't want to leave anyone behind, and I want to make sure that we are able to even see how you can transform this and use them somewhere else. Now, obviously, like I've said before, Toby, Chima, you have to know more than us. You know, Sina and Ariba is more advanced because she also comes from, she's just coming back to medical school now. So this may be stuff that she's familiar with, but I just want us to have a rock solid foundation about approaching a machine learning project, okay? So feel free to just jump in. I know it's simple, but that's the good thing about having a rich diversity. And Pre is being fun, but very quiet. So the next thing that we do here, which was great, was these categorical variables, right? Remember we looked at info, which showed us our numbers and these categorical variables. And you can see this as, we know this function of head, which is like, show me the top 10 rows, right? And you can see all this variation. Now, the way to do this is that you can use this scikit-learn method called Ordinal Encoder to convert, because if you think machine learning is math, so if everything has to end up being a number, whether it's natural language processing or whatever it is, so you have to make it a number. And so these are the strategies that they talk about making a number, right? So here they go and say, why don't we use this encoder class? And you can see that in this case, we're using fit transform, right? Remember we said fit transform in terms of this, and fit transform is optimized and runs faster. If you look at the estimators and transformers here. And so to just see what was done is that now these are randomly generated in this fit transform 004100, and they're random, and so like what does, obviously categorical variables, you may say that this is 00 is this one ocean, and then 4 is near ocean, and inland is 1. So obviously if you have this, it's going to be 0. So this is what it's done. And remember, if you just do the underscore original encoder categories, then you can get the statistics from that method. But what they say is that machine learning algorithms assume that 2 nearby values are more similar than 2 distant values. So, and this may be good when you're doing like a category like bad, average, good, and excellent. But in ocean proximity, it doesn't mean that 0 and 4 are more similar to other, like ocean and inland. Maybe some things may be nearby, but island and near bay may not necessarily be similar. And so what they say is that to fix this issue, which is good because you'll hear this term come up a lot, is to say a common solution is to create one binary attribute per category. One attribute is equal to 1 when the category is 1H ocean and 0 otherwise. Another attribute is equal to 1 when the category is inland and 0 otherwise. And this is what's called one-hot encoding, okay? Because only one attribute will be hot while the rest will be cold. Very important concept to understand, okay? So all your categorical variables, so you can see you can ignore this ordinal encoder, right? And you can say, I'm going to import from sci-kit learn this method, one hot encoder, and I'm going to do the same thing, which is fit. And you can now to start to see, you get these arrays that show only the thing that's present at one point is 1 and everything else becomes 0. Are we together?
This is a really good concept. I really liked it this way.
Yeah. Okay. So
So actually, before we move on, Santa Patricia, could you, so I guess looking at what happened right before that, so we had that number 4 for the, what was it, inland?
yes.
So I didn't get to how we only have zeros and ones when you have more than 2, I guess,
Yeah, categories.
options per category. Yeah. So how does that, is that confusing? So your multiple things will be zeros at the same time? I didn't quite get that.
So I think, so like, if you see the first value, basically the order is the same. So are you talking about the one-hot encoding, or are you talking about the,
So how did we move from ordinal encoder to one-hot encoding?
okay, so with no ordinal encoding, let's say, now let's use a different example. Like, let's say, let's say you have a field that has person, like description about a person. It's, let me see if there's a good example. Boy, girl, man, woman, right? These are four different things. With the first one, with the, what they call ordinal encoding, you say if the person is a boy, assign the person 1. If the person is a girl, assign the person 2. If the person is a woman, assign her 3. If person is a man, assign her 4, right? Or something like that.
Yep.
Mm-hmm. But with one-hot encoding, you have sort of a vector, or just sort of like an array, and it has 4 values, like the one that's there. And then if the person's a boy, then only the place that is a boy is on, and all the other places are 0. If that makes
I see, that makes sense.
Yeah.
So I guess each text has been configured into, like, it's not binary anymore. It has 5 attributes. Okay, that makes sense. Got it.
The reason for it is, like, if you're training the machine learning algorithm, like with the original one, let's say it might assume like a woman is 3 times like whatever, like some weird thing. It'll just assume like a woman has 3 times more powerful, or like a man is 4 times, or a girl, which is very dangerous. But yeah. Yeah.
Okay.
Okay. And just, we had like 5 categories for the ocean proximity, right? And that's from 0 to 4 because it has 5, 0, 1, 2, 3, 4. So it's just basically, and then on that code, the reason that you're seeing 10 of them is that we define that, just show me the first 10. So so the first 10, like 2 of them was in category 0, the first 2, and the third one was in category 4, which was like probably island or whatever. So it's basically in Shima's case, we had like, 4, so it would have been 0 to 3 if we used this one.
With computer science, most indexing or starting values start at 0 rather than 1.
Great question. So this is a tip provided here. You know, if a categorical has a large number of possible categories, like country code, profession, species, and you'll see that in the example test that I gave you, this will result in a big input number of features, right? We talked about big dimensions, right? Remember, we don't still have those supercomputers that can take in a lot, or if they're there, they live at Google and other companies that we do not have, right? And so we always have to, you know, narrow down the dimension, right? And so you could, for example, start to say, you know, so this is important because it gives you fundamental of understanding NLP. And, you know, so if you do this one-hot encoding, you can result in a large number of features. And so this may slow down training and degrade performance. So what you may want to do is replace the categorical input with useful numerical features related to the categories. For example, you could replace the ocean proximity feature with distance to the ocean. So you have to think to yourself, what can you replace with a numerical value so that you get rid of this one hot and categorical variables, right? So a country code could be replaced with the country's population and GDP per capita. Or you could, alternatively, you could replace each category with a learnable low dimension vector called an embedding. I don't want to go down this embedding pathway, but we will talk about it. And each category's representation would be learned through training. And this is an example of representation learning. We will do that in chapter 13 and 17, okay? So all it's saying is that don't be so like focused on the data that you have and you forget, maybe instead of getting these embeddings, why not just get the distance to the ocean, right? Or something, or the distance to the mountain or something like that. And so, you know, this was like to show like a custom transformer, and all this code is doing is trying to get, you remember like we were calculating some things like add bedrooms. So if you went back to this code, this one, where we added rooms per bedroom, rooms per household, bedrooms per room, population per household. This is a little bit of what's happening in this custom, you know, transformers, where you're saying, you know, create this complex code that will do add bedrooms per room, and this is true. And so this in this transformer, the parameter has one parameter, which is add bedrooms per room, set to true by default. And this hyperparameter will allow you to easily find out whether adding this attribute helps the machine learning algorithm or not. More generally, you can add a hyperparameter to get any data preparation that you're not 100% sure of, right? So the good thing about Pri, do you want to walk us through the code for this? But these transformers, the only thing that I noticed was that if you spend the time writing the transformers in your pipeline, you can figure out what's useful or what should you get rid of. Abid can also do the code walking, Chima, Toby, if anyone wants to do it. I don't want to spend too much time on that because I do believe that.
I really wonder if any of them can read this code, because I had like, it took me a while to like, it needs to sink in basically, just defining classes and like defining functionalities and methods under the classes. And like that, I don't understand that room underscore ix that we first assigned some numbers to. Particularly that one, that part was confusing. So if anybody can.
This one you're just declaring the variables, right?
But
bedrooms, population, household is 3, 4, 5, 6. Then this.
Why are we using those numbers then?
Because you're gonna use them in your code.
No, why did we choose to start from 3, 4, and 5?
I don't think I spent too much time trying to figure that out.
Pipeline was to me. The entire pipeline structure thing. It was well. I thought it, for me, I always thought it was something that was more conceptual. In a way, I hadn't ever coded a pipeline.
Well, I can explain a bit. Hello?
Yes.
Yeah, basically the second line, if you look at the rooms IX, bedrooms IX, they are scoped out of the class. That means it can be accessed throughout the whole program. So you can use those variables inside your class. You can use those variables if you declare any other methods. So basically, they have declared it as a global. If I say that as a global variable, and inside class they are using those variable to I guess they are using it in their transform method. So if you're calling combined attributes dot transform, those variables will get used, and you can use them in a class if you are defining it as the class variable by self dot rooms underscore ix. If you define some sort of variables, that will become a class variable. Am I clear?
Not really.
Okay. So
We can hear you clearly,
consider,
but I don't think.
consider it this way, like there is a variable which you want to use throughout whole your program, whole your Python program. So, and that has a global scope. So if you define a variable a equals to 5, until and unless it is not changed throughout the program, it will remain 5. If you are changing its value inside class, if you are setting var a in class to be 6, so for that class only, that a variable will be 6. That, does that make sense?
Yeah, I mean, what Pri is saying is that these are global variables. You just insert
Yeah.
them here. But when you call this method, then you can use them within this class and they're going to be changed. So def init,
And take,
I think I understand the values 3, 4, 5, 6. Those are indexes. So if you look at the line on the
they are,
transform,
yeah, they are assigned.
those are the indexes of X. X's are a feature. X is like all our data. Because they seem to be doing like index, they seem to be calling out those specific columns.
Yeah.
0, 1, 2, 3, 4, right?
5.
You have defined that indexes, that these variables will be 3, 4, 5, 6. If you change them, they will become a different thing.
They were not random. Ignore what Judy said. So rooms IX is this one. So it's 0, 1, 2, 3, right? Then bedrooms is 4. Then population is 5. And households is 6, right? And I'm just counting from 0 here. And those are just our columns. So these refer to the indexes of the data that you're bringing in. Okay. And so now you initialize, which this is just a way to initialize a class. And then you fit, I don't understand what that's supposed to do, but the rooms, which is the transform, is that the rooms per household is equals to, you're going to get the rooms over the household, which is how we were selecting. But I do believe that this X is probably the data frame that we're using. And then the population per household is the population over the household. And then, so then add then the bedrooms per room, if you have them. And so then now you're going to return an NumPy array with rooms per household, population per household, and bedrooms per room. Else, if you don't have bedrooms per room, you're going to just return rooms per household and population per household. So I think I think X must be our data that we are bringing in here.
The transform data.
Yeah.
And you'd be returning either the bedroom per household or the other.
Yeah.
I didn't know why they needed to do this because I thought they already did it before.
Yes, but I'll explain to you. I also was like, why would you do this? But I got it actually afterwards. So it's coming. So feature scaling, right? Feature is just the same way we said some things are 1, sometimes are thousands. And so you need to normalize them to become standard because you're feeding them into your machine learning, okay? And so, so there are 2 ways. You can either do min-max scaling or standardization. And min-max scaling, which is called normalization, is that values are shifted and rescaled so that they end up ranging from 0 to 1. Okay, and we do this by subtracting the minimum value and dividing by the max minus the minimum. It's just math. So you can use this math transformer called min-max scaler for this. Okay, and standardization is different because it subtracts the mean value and then divides it by the standard deviation so that the resulting distribution has unit variance. So unlike this normalization, this it's not bound to a specific range. and which may be a problem for some algorithms, because some, like neural networks, often prefer an input value ranging from 0 to 1. Okay, but standardization is less affected by outliers. For example, a district has a median income of 100, equal to 100 by mistake. A min-max scaling would then crash all the other variables from 0 to 15 down to 0 to 0.15, whereas standardization would not be much affected. So, and you can use the standard scalar or the min-max scalar for this. And I think, so this was the, actually in this code where we said, so if you look at how we use this custom transformer here, is that housing extra contribute, add transform, and this is where we call it here. And then we say which columns are being added, which is rooms per household and population per household. And then the index. And now all of a sudden, if you look at our data, we have rooms per household and population per household. It's an easy way of generating and normalizing more functions to do. So I do believe that we can explore this a little more. And so this is the scaling, this is the pipeline. And what I like is that all that work we've done, you can just use this code and your data is ready for machine learning. Look, we said import pipeline and import the standard scalar. So then the numeric pipeline, right? Always remember the numeric and the categorical variables will be different. So numeric pipeline, you put them in pipeline. Imputer, remember, we have to fill all our null values, right? And in this case, we are filling them with simple imputer strategy from the sci-kit plan. Then we're going to add attributes, and this is combined attributes adder. And this is just these new rows that we're trying to add. And you can see that we're calling this class combined attributes adder. This is why we were writing, they were forcing us to write this as a custom transformer, so that you can just call it in your pipeline with one word. Else you can do the other way still and it's fine. And then we have to scale this either by min-max or standardization, and we scale this by standard scalar. And then you fit transform to apply your pipeline, which is this, the housing numeric, which is the data frame that you want, okay? And so if you look at the column transformer, which is the categorical variable, which was the ocean proximity, you can see that here you're calling the column transformer. And so this is the full pipeline here. So the numeric, you want the numeric pipeline, which is this one, okay? And we are doing only the one hot encoder for the categorical pipeline. So then in this case, if you just apply this, then it just completely, you'll hear this word pipeline a lot, even in our lab meetings, right? Is your pipeline ready for machine learning? And this is how you use the scikit-learn for your pipeline to make sure that this is done. And once you're done with that, this just showed a little more of sort of merging like all the pipelines into one, where you say the old numeric pipeline, this was selecting these attributes which we've gone through now, and this, the categorical pipeline, was using one hot encoding, and now they're even making it shorter, that you don't need to write all the code and you can just use this to transform. And now in all this point, now you have your data. When you just run this code, you have your data that's ready for machine learning. Questions, comments?
I thought for me, so I've always had the notion of a pipeline as sort of more of a concept than I've never in a class for it before. I don't know if anyone else had, but that was new for me in terms of like writing those few lines. I thought it was more like, oh, you have something, you go from here, and then yeah, that was something that was really new to me. It was writing code for a pipeline.
Yeah, but if you think about pipelines, right, they always vary. But Chima, if I give you an assignment, I may give you the wrong data now, right? Or the data may be insufficient. So if you have to always go back and write the code, it takes too long, right? But if you write your pipeline this way, you know that every time you're going to discover what variables. So we've done already all the data. Let's say I'm just giving you a bigger sample size with the same data field. I'm not introducing a new data set, right? So you look for null values, you're going to convert your categorical values, and then you're going to scale so that everything is in the same number, right? So those were the things that were required for this pipeline for managing this housing property. So now you can imagine that you can modify this pipeline to deal with the bigger data set, the one that we want to try on Kaggle, right? To work on dealing with multiple things, and maybe your transformer will come up with something better, right? But all of a sudden, we've all these, what I like more was that if you spend the time putting up like the pipeline, it doesn't matter, your code is clean, right? You can bring a new data set and it's easy to just run machine learning on, right? And so, you know, then we finally get to the place where we're doing the machine learning. And I think we went through the Null free lunch theorem, which just says you really cannot know what model will work best, so you have to try a couple, okay? And so we start on the training set using linear regression. Here is what we are importing here. And here we're just saying, if you want to call a machine learning model, you just say fit, and you're putting the housing prepared and your labels. And if you remember this, when we were starting this code, we separated the labels earlier. And if we sort of went, not even fine tuning, let's not fine tune. Here, you know, so you can say, select some data, and this is just a way to select using the iloc function, and select some labels, and then, you know, full pipeline transform that data, and then predict, you know, predict some of the data prepared. And so, well, remember, your predictions have to always be compared to your y hat, right? Which is the actual value, right? Which is why we remove the pricing. That you cannot have your training data with the price. You cannot, because the model will learn the correct price. So you remove that column that you're trying to predict, and now all of a sudden you have, these are your predictions and these are your labels. So now you can start to see, well, this is the real one that should have been there. This is 317, this is 340, this is 219, so you can see the variance, right? And this was the data that was prepared. Now we have to go back and now tie back our earlier concept, which says, okay, how good our model is present, you know, doing this. So now you remember we talked about the mean squared error and the mean absolute error. And now you can see that the mean squared here is 68,000 and the mean absolute error is 49,000. So, you know, and here what you're saying is that the most district housing values range between 120 and 265. So a typical prediction error of $68,000, that's how far your model is off. It's not very satisfying. So this is an example of a model that's underfitting the training data, because we don't have enough features to provide good information. And so the solutions to dealing with underfitting is to select a more powerful model, or to feed the algorithm with better features, or reduce the constraints on the model. So we looked at this and we're like, you know, gee, this is not very good. So why don't we try another model, right? So all you need to do is change this linear regression to decision tree regression. Do the same thing, because your pipeline is amazing. And now you get the mean squared error, but now we have an error of 0, which is crazy, right? So what we have to do is that this model cannot be perfect, and this is a case of where you have overfitting on the data. And so you have to keep now going back here, and what they move ahead here is this cross validation, that you want to still split your validation. And we talked a little bit about this, like the cross validation feature, which is like 10 distinct subsets called folds of your data, so that you can fine tune and get better. And so what happens here is that sci-kit apparently has this, you know, cross validation score, and here you're just saying that you want 10 subsets of that. And so now if you look here, it's going to run this 10 times, right? And so it just shows you 10 RMSCs, and you can be like, oh, 70, 66, 72. So by looking at this, you can see that the decision tree model, which had an overall RMSC of 0, is not performing better than the linear regression model, which had an RMSC of 68,000, right? Because if you look at, for every cross validation that's going in, we see now we have a mean of 71,000, and all these values, most of them are above 68,000. I'm going to stop there just to hear and unpacking different versions, what people thought about this. You know, this is just showing how you use cross-validation to improve and understand how your model is performing, so that you can figure it out. Nothing? Okay. So we've done the linear regression, we've done the decision tree regressor, right? And so, and we've tried to explore this cross-validation to figure out how is our model working. So then we went to random forest regressor, right? And if you remember chapter 1, it had these types of, you know, things that you can do for supervised learning, you know? And in this random forest regressors, they work by training many decision trees on random subsets of the features, then averaging their predictions. This is what random forest regressor is. Same thing we did. I mean, this is just like copying code now and just going really quickly. And so you can see that in this case, we get a lesser mean of 50,000, you know? So the score on the training set is still much lower than the validation set, meaning that the model is still overfitting. And so possible solution is, again, to simplify the model, constrain it, or get more data. But you should keep trying many things, and which is one of the assignments there. And the goal is to end up with 2 or 5 fitting models. And the way you know that it's performing well is please use the cross-validation and look at the RMSE and the MAE. And so the other thing that was important here is, which I didn't do, but should be in your code, is that you should be saving your model, right? Because you don't want to figure out, oh, gee, the decision tree or, you know, the random forest regressor worked better than one other model, like the decision tree regressor. Now you have to retrain it again, right? These are small, they're running okay, but if you've been spending days training, you don't want to come back to that. And so, this has to be a good trip. And so the last step where they come here and they say is that you have your top 2 to 5 well-performing model. Now you have to fine-tune them to make sure that they learn better. And so there's this one function you can use. One, you can look manually, keep changing all the parameters, or you can use grid search CV to help you do this. And so they show how the grid search works here. You can see the estimators, the maximum features, the bootstrap, the number of estimators, and the max features. And you initiate a random forest regressor, and then you grid search, which is just saying, find for me some of the best, fit some of the best parameters that I should be using. And this parameter grid, which is this one, tells sci-kit learn to first evaluate all 3x4 combinations of 3, 1, 2, 3 by 4, 1, 2, 3, 4 of n estimators and max features parameters in the first dictionary. And we will look through these parameters more in chapter 7, and then try all the 2 by 3, which is 1, 2, 1, 2, 3 combinations of hyperparameter values. So first try evaluate this, and then try this. And and then, so this grid search will explore 12 plus 6 combinations of random forest regressor hyperparameter values, and then it will train each model 5 times, because we're using a 5-fold cross validation, which is this one here. And in other words, all in all, there will be 18 times 5 rounds of training to try and get you the best model. And so when you come here, you'll say, show me the best parameters. And what they said here was that if you look at n estimators, the best parameter was 30, but we had put 30 as our maximum here, and maximum features were 8, and we had put 8 parameters. So you have to go back. These were randomly started, so you have to go back, and now, since 8 and 30 are the maximum values that were evaluated, you should probably try searching again with higher score values, and the score may continue to improve. Okay, and so this underscore thing again is how you get sort of statistics if you want to figure out the best estimator. And by just using your grid search, you can get the best estimator here that shows you that you should be using the max features, which were 30, and the n estimators is 30. And so you can also go underscore, the same thing using the underscore, where you can go look at the grid search CV results, and you can see all the possible combinations it evaluated and what were the best, okay? And you're looking at the scores here because you're looking at the mean test score And if you look at 8 here, so 49,000 is probably the least here, and this is why it's maximum features of 8 and estimators of 30. And so you can also, so you can use grid search CV, or you can use randomized search. You know, so when the hyperparameter space is large, you should use the randomized search CV. And you know, if you let the randomized search run for 1,000, it's going to evaluate 1,000 iterations. And obviously, you can ensemble the models. And so the same thing again here, you look at the best grid estimator and you look at the scoring. And so if you look here, what they were saying, for example, if you look at the random regressor model here, you can figure out, this is important, you can figure out what's feature importance, right? That's another word you will hear a lot of. What can we throw away and what's going to be important for us? And I thought this was great because you can start to figure out that the median income, if you're inland, because you're starting to see how it's sorted out in the island, you know, you can start to drop out things like ocean proximity thing, because you can see all these are pretty close to zero, you know, less than 1% near the ocean, near the bay, all these things are close to zero. And so they're not as important. And so that's how you start to trim down your data of all the features that are not. And then once you've done and you've fine-tuned your model, now you're ready to test it on that holdout test data set that you kept away from the word go. And the only way you need to do is you come here and you say, your final model, show me the best estimator, and then X, which is your test. You drop the median house value because that's what you're predicting, and Y test, you make a copy of that, and you do your full pipeline. We walked through this, which deletes the null values, scales, make sure that the scaling is correct, and imputes and takes care of the categorical variables. So you come here and you run on your X test, which is your data here, and you say your final predictions. Model predicts the X test prepared, which is this one, and give me the final MSC, which is Y test and the final prediction, and final RMSC, which is just done this way. And so in some cases, so if you, such a point estimate may not be quite enough. You may need like, you know, what if like 0.% of the model is better than the model currently in production. So what you should do is compute the 95% confidence interval. We talked about this when we were talking about the scoring, and you use this t.interval method in SciPy. So you're importing SciPy, importing stats, putting your confidence. So if you wanted a 90% confidence interval, you put 90 squared errors, square root, and you'd have this array of your 95% confidence interval. And so then now at this point, you would launch your model, and we will get to this someday, where you'd put your app, and then you'd learn, and you'd collect new data, and you'd run and fine tune the parameters automatically as you get more new data, and you'd monitor the performance so that you make sure that your model is running okay. Questions?
So when you launch your model, does it switch from batch processing to online processing at that point?
No, unless you made it that way, right?
Okay.
Yeah.
Mm-hmm.
I'm gonna pick on everyone. Toby, you've been very quiet.
Yeah, I have a question. So based on the standardization and
a question to the whole group, yeah?
No, okay, to the whole group. So standardization allows us to normalize that to for standardization, our mean is 0 and variance is 1. No, for normalization, no, that's standardization, yes. So for normalization, we can either normalize from 0 to 1. So there was a project that I worked on, and when I tried normalizing from 0 to 1 and calculating my MAP, I had an infinity score. So then I tried -1 to 1, and then I still had an infinity score. In this book, there was a caveat that stated if you're working with a neural network, you should use from 0 to 1. I want to ask if it is fine to make use of 1 to 2, if it's okay.
Oh,
I don't know.
I'm not sure.
says that you even have that option here.
I don't think it does.
I think so.
You have to speak a little louder. It's raining now.
So it says you have that option here. You can just define your range. It doesn't have to be between 0 to 1. So maybe that will be of some use.
I honestly don't know, Toby. Pri, do you have comments on this?
No, I also don't know. Like we generally do 0 to 1. I don't know why not 1 to 2. No comment.
I don't know. So the good thing about the book club is now we all have to go read about this, and maybe you should share that portion of the code, and then we'll try it and see why you are getting the error. But yeah, I don't know. Any other comments? What did you think about this? Was it intimidating, Abby? We haven't had you say anything throughout the whole.
I think for me, with everything, I was just concentrating on not getting syntax errors, making sure I'm doing it the right way, and kind of like trying to understand, okay, this is what we're looking for. Like the part where you were talking about the element of the variables like 0, 1, 2, 3, 4. I think I understood that. So, I mean, slowly, I'm getting there slowly.
No, that's great. Like I said, don't give up. Go back and rewatch both of them. This is why we record them, right? And then read through the chapter now. And then I would encourage people to do these exercises, to be honest, because it's just going to help you consolidate. Sina, are we going to discourage you from coming?
No, it's good. I mean, a lot of the code kind of goes over my head, to be honest with you. I'm trying to understand it and Google a lot, but it helps to kind of understand the thought process. We're listening to you guys kind of go over stuff. So it's been really helpful, actually, getting them more comfortable. Now I'll be coming back, don't worry.
Okay. Elmira, I can tell you like this book.
Yeah, I do like this book. One thing that I wanted to point out about that.
We can't hear you very well. Or I cannot hear you very well.
What about, how about now?
Yeah, we can.
Okay, good. Sorry, I didn't know what happened. I haven't changed any setting. But for that cross-validation part, I think he just passed through that area a little faster. But I really think that that makes it sink in my mind of what cross-validation is, that you separate your training data, just the training data, to just some actual training data and some validation part, validation data set. And it really was really helpful for me to know that when you first, let's say we haven't split that to training data and validation data. And if you just run one of these models that we have, like, let's say random forest, for example, if you run that and we get like error score of like 0, we don't know that if it's doing too good or if it's just overfitting. But if you run it only in your splitted data just for training and then use the rest of the data to cross-validate, if your score gets worse, well, if your score get worse, that means that it is overfitting. But so that's like one of the ways of understanding what's happening in your model by doing that. So I think he just said, oh, by the way, just use that split function and just do that testing and like not testing, training and validation test. But I think it's important to like get that concept and like what that validation data set means and what the importance of that is for us.
Absolutely. So a few things, right? I would say that please go back and read through this chapter again. I really do think that we need to talk about. I would say that let's tackle this challenge. The good thing about this challenge, the housing prices, it's really for making you get better at figuring out this you know, these rules. Once you've created your account, we can make a team. Okay, so you know, so you know, so you just when you create your account, let me know, then I'll add you to our team here. Okay, and what I want you to do is just do the end-to-end, really, using this data, because it's going to be around houses. You know, go back through and see, I mean, the way you can just go back like step by step and say, oh, let's see the categorical variables, work on those. Let's create pipeline, work on those. You know, the transformer part may be a little challenging, but you know, we'll see what other people do with their transformers, right? And then submit your prediction. You just, I mean, this, what I wanted is that you can read this and be like, I know exactly what they're saying, right? You know, they're like, ask a home buyer to describe their home dream house, and they probably won't begin the height of the basement ceiling or the proximity of an east-west railroad. This playground competitions data set proves that much more influence price negotiations than the number of bedrooms or a white picket fence. With 79 variables describing almost every residential home in Ames, Iowa, this competition challenges you to predict the final price of each home, right? So you know the column that you'll be dropping from your data set before you predict, right? You know, you're going to, you know, you're going to, there's even a Boston housing data set, but let's start with this. You know, you can look at the data. I just walk within here. You can see what the data description is, right? So you may not even need to like go back and do the variables the way I was doing them to see it, because you already have a data description, right? And you can just spend time thinking about this and figuring out what am I going to merge, what's going to be my transformer, come up with your pipeline, and then ultimately what you should do is you should end to the point where you make a prediction, and you can see that the task here is the evaluation, which is how you always do, is that you should end up with a CSV like this, and you should just be RMSC is the value that you want to predict, which now we know how to calculate with the sci-kit plan. And then I would say go ahead and submit your score, and you can see how you perform by just looking at this. Okay, so these are very small errors, right? 0.004, right? Very small, the error of RMSC, so it's a very good prediction. And then we can discuss what worked on people, what did not work for people. I do believe that this is we have some tools to just get out there, don't worry about failing, and just try it, just passively. And we have a good end-to-end machine learning thing, okay? No? Am I gonna drop some people now that I'm giving assignment? So the next week, so that should, the challenge should be something that when you just spend like 30 minutes every other day, work on it a little bit, let's use the chat to the Slack channel to talk about it, so that we use more of this joint time together to discuss it. So the next thing we're gonna do is this classification task, right? And who's going to volunteer to lead us through this task?
Yeah, I'd love to volunteer.
Awesome, Toby. Awesomeness. Okay. So next week, 11:30, let's come discuss chapter 3. In the meantime, I'm curious to how people will perform. Nazanin, we didn't hear your voice. Are you there?
Yes. Hi. I'm Nazanin Tafreshi. I've studied computer engineering at Khaja Nasir from Iran. And I'm interested in machine learning in healthcare and also medical imaging. And I'm working with Dr. Judy and Dr. Banerjee from Emory University now.
Awesome. Thanks for joining. Any final comments?
I just want to vote in terms of, so I'm more than okay explaining code, because I came from, like, I'm volunteering myself in terms of if you have problem with code, I can definitely help you out.
Awesome. You know what would be great, Tima, is if you could, you know, on task 2, on this task, they have like a task to create some more transformers. If you could just spend a little more time getting like some good transformers And feel free to make even like short videos about the transformers, explaining them, and just like, because I do believe that these people, this kind of was very intimidating. And so like I think one of the assignments here is to go back and create, try adding a transformer to select only the most important attributes. That would be like super important if you could do that for you know, and and remember I said, guys, you have to own a blog, especially the CS people. You really do have to own a blog, right? So that like what you're gonna do, Chima, you'd write it in a blog and then post the link here. And then people can see, okay, now they're starting to see sort of what you're doing. You can use, just make a screen recording, say this is what's going on. So that, if you did that for the transformers, that would be amazing.
Okay. Yeah. I'll try.
Yeah.
I'll try.
You're not gonna get away from leading the discussion in future, but I would appreciate that.
Yeah. If you have any problem, just DM me. I like especially. I do like teaching or like dealing with stuff with CS. That's why I like that a lot.
Awesome. Okay. So we're gonna go pre. Very loud.
Yeah. Sorry.
No, I'm just making fun of you.
Yeah. Well, I found just two more metrics to add to the regression. Like we use, one is the R square and one is the logarithmic root mean square. So I mean, we often use those metrics in the regression task. So just added that. And one more thing is I posted a feature selector library which I used without knowing the concepts. So well, this book was very much help on the Zoom chat.
Okay. I don't see it. Oh, Zoom.
I sent. Yeah. So yeah, I use that without even knowing what is inside. So well, this book is helpful. And sorry.
Could you add it here?
Yeah, I'll post it on the Slack.
Yeah. Okay.
This is a very good book. Like I'm getting to know what are the basics.
So that's the thing, right? I mean, Toby, Pri, Nazanin, they build, and you, Chima, you guys build models, I know, a lot, right? But this book is just about fundamentals, right? You want to understand. And I don't care, honestly, at the end, honestly, if, you know, Sina says, Judy, I'm never going to build a model. That's okay. But I want you to listen and be able to read the paper and be like, I know exactly what this is going on, you know? And so that's what I'm saying. With Colab and Kaggle, I know Elmira will build models, I can tell, but you know, but don't be like, oh, this is too much above my head. No, I want you to be able to read the paper and be like, oh, this paper was not properly done because of this, or I have this machine learning project. This is how I'm going to approach it. You know, Abby, I want you to be able to be like, when I put you in a team with Toby and Chima, you can tell them from the clinical point of view, I think this is wrong because of this, right? That's what I do best. You know, I don't actively build code every day, but I can tell you, I can look and be like, oh, this doesn't make sense. But this just gives you, before I give a machine learning project to people now, because as we do this book, I'm going through and creating my pipeline. You can imagine now with the help of Chima, if we understand more how to build sci-kit land transformers and how to build your own, you'll get this tooling by the end of this book that you can quickly do a project. And so if you have new data, like right now I have some data on, we know we have the National Trauma Database data set that has lots of interesting questions you can answer, and it's available to us in the lab. And once we get to a good point, it's easy to analyze that data set, right? And now we can start, for someone like, so now you can start to say, gee, I just want to figure out what happened to these trauma patients, right? But now you have the tooling that allows you to do a deep dive and to figure out what are the important features, what am I going to throw away? So on Mondays, when you hear someone say, yeah, let's just use one-hot encoding, and you're like, I know what that is, you know? Or then I'll be like, oh, what features were important, right? You know how to get the important features if I give you a data set, a tabular data set, right? I just want to expand the vocabulary, but have the understanding. But I think the reason why we chose this book, really we're going to use the other book by Jeremy Howard, was that I think a little bit you get good, especially like Chima, if you're good at reading code, getting other people's code and putting it and making it work, but you have no understanding of what the whole process is. Okay, so look forward to an interesting discussion this week. Keep dry out there and don't give up. And see you, Toby, next week. I'm looking forward to keeping quiet. I may have to create a new room because usually I have something that may like just extend by 11:30 or something. So that we all is able to use this Slack channel, this Zoom meeting. So I may create just something different and send it out to everyone. And then I think that's it. Any feedback? Oh, I was gonna go around. People can say their final words. Chima.
Thank you.
Okay, Toby. And you cannot not have internet or electricity. You're not gonna trick me. We can't hear you.
Thank you so much. Yeah, today was really awesome from my end. I learned a lot, and I'm totally grateful for this opportunity.
Amira.
I'm really excited, and thank you for all of you, particularly Shima. Thank you for offering your help with like if you have like problems with codes and you can just walk us through. Like that's really important. Thank you.
Yeah, just DM. Just if you want, you can just DM me. I'm pretty responsive.
Okay. Abby.
Thank you, everyone, in all of this discussion. At least slowly I'm getting there, and I'm gonna keep doing it. And I just want to say thank you for having me in this group.
Awesome. Sina.
There you go. Okay, yeah, just same. I'm just I think it's kind of intimidating to get into all the coding thing. I've always wanted to get into it. I've never gone to, so it's really cool to kind of get into this. And I'm really passionate about it, and it really helps to kind of hear you guys explain things. So thank you so much. I appreciate it a lot. Yeah.
Great. Please,
Yeah. So thank you. I mean, I'm learning new things, just the basics, which I don't know. So the questions are much more important here. Like we do have doubts, but in a group we can clear it out, and it's easy to learn in a group. So yeah, thank you for involving me.
Nazanin.
Yes, thank you. This is a really good book, and I think at the end, all of us will learn really useful things from this book. Thank you for this book club.
Awesome. Okay, thank you, everyone. Goodbye. Yeah. See you next week.
Bye.
Bye.
Bye.